Cupix. I'm the CEO slash and CTO. And then I'm very excited to be here. And actually, I thought this is very technical conference, so I prepared something that very interesting new emerging technology, which is neural rendering. And so as we read this, I'd like to give us some glimpse about what we are up to as a company. Okay? All right. So maybe some of you don't know what we are doing as a company. And so I have some slide that I can explain so our business as well. Okay? Right. And so before we get started, I'd like to give some background about myself. And so Cupix is my actually third company. And before that, actually I studied as a computational geometry is my major. And somehow from young age, I was very fascinated by this kind of concept, right? Reality capture, point cloud. And so my first company focused more on this, some idea about using the scan data for manufacturing industry. And so we built something very similar to scan to beam for mechanical engineering people about 20 years before. And then I developed something for inspection using just a non-contact point cloud data, more like a sub-micron data, and then that accuracy went through all different type of certificate and all the detail of accuracy side of things. And then I moved to more like a more generic application, like a body scanning or DICOM. And then my last company was about to provide a way of collaborating on web-based. That is more like 12 years before. So actually this is a federal data. And so I tried to build some web application to handle massive point cloud like this. And I work for, after that, 3D printing company like 3D System to help them to build some cloud backend system for printing industry. So like you see here, actually I'm not the AC people, right? Up until 5 years before. And so, but I believe I'm very familiar with this technology. Also, all the time, my best interest is to how to put together some different vertical, different technology together, and then create some new value for certain people. So that is my sweet spot. And so when I started working on this AEC solution, it is very interesting. And so I learned a lot. And so I try to now bring my perspective and insight for some certain problem. So we try to solve together. Okay, so enough about me. So next slide is the main topic of today. So maybe you have heard about this new cool concept about this NERV, right? I think this neural rendering typically is referring to this technology NERV, not this NERV, right? So some NERV thing. And so actually what happened is 2 years before, there was a very ingenious guy from Berkeley, Google, and then they made this presentation at one of our international computer vision conference. And when I first saw this, I didn't get it. I didn't understand what it is. But our researcher, our engineering team kept pushing me to look into this. You have to look into this. And so once I understand this, what it is, some basic idea, and all the detail later, is so fascinating. It's so different and also so beautiful, right, in many ways. So main idea of this is like this. So this is everything. This diagram illustrates the basic concept of this neural rendering, which is, so what if there's some kind of computer brain that can be trained by this photo like this. And then this brain can be trained that way. And so then if you have some kind of the query, like if from this given photo, then what it will look like if you add some the color value of a certain pixel from this position, this angle. And this function f is smart enough to give you the answer in a very fast way, like a 30 frames per second, that frame rate. So you can infer your certain pixel color value from this trained model. Okay, so it is so cool idea. And so actually Azure is a conceptual modeling all other infrastructure like GPU and CUDA and all different technology from the machine learning side enable this, right? And so since this their initial research, it became phenomenal, like this. So last couple of years, many different type of this international computer vision, including SIGGRAPH, there have been an immense amount of research paper, right? So just this year alone, just one conference alone, there are about 50, 70 kind of paper, one single topic. This is neural rendering, right? As well as it's academic research, some big giant tech like NVIDIA, Google, Waymo, they jump on this. So this is one example. NVIDIA, for obvious reason, right? They are watching into this idea. So they announced some kind of experimental library. You can train that brain really fast. Meaning fast means like within several seconds. So let's say this photo, this one. So she took just a matter photo, and then from the surrounding angle, and then this NVIDIA kind of their algorithm can finish all the training, for instance, in 10 seconds, and then in real time, you can see that realized that trained model from any angle, from any position, right? So it's not limited to just a small object or small space, like a Waymo, right? So they announced this, share this, their research result several months before. It's kind of a series scale neural rendering, right? And so Google, last their Google I/O conference, also CEO, just a little bit about their speech, he mentioned that they are working on some this immersive neural rendering thing for everybody, for Google Maps, right? And so, again, so main benefit of this is so simple. So to me, it looks very beautiful. The concept, all that the process, train the model from the many different bunch of photo. It's more like a photogrammetry 2.0, right? Once you train the model completely, then now you don't need to carry around point cloud anymore. You don't need to carry around the mesh anymore to visualize it, right? Even 6 degrees of freedom model. So Cupix, as a company, we also provide something like the Google Street View, somebody described that way, for your job site or your facility. And then it is great benefit for us too. Now, because we know if we have some tool like this, we don't need to have that kind of a discrete, right, 360 photo-based photo, kind of a pseudo navigation experience. It's going to be complete, just 3D navigation experience, as well as a visual. Also, you can get some geometry information, like a dimension measurement, from this model as well, right? And so, our team is very much into this as well, and so we have some idea. I can explain some later. And so, then next possible follow-up question is what possibly that the impact on this technology on us. Us means us, right? This reality solution provider or users, everybody. And it means that this whole point cloud mesh and 360 virtual tour thing will be there. very soon. And so we know this. Certain time, there's some evidence that technological disruption can kill business, right? Sometimes in a very big way. So it has some potential like that. So that is kind of question to me too, right? So also it's not right complete answer yet, but I think this is a great kind of the topic is worth thinking, right? And so what is the implication? But my 2 cents is that here's good news. So maybe not, right? Maybe not that soon yet. So there's some kind of the benefit, right? So it's more like a novel view synthesizing in a very realistic way. So it's photorealistic, reproducing some unknown pixel from the trained model. And also it's very compact. What you need to keep as a brain is just that brain function that is so-called MLP, multi-layer perception model. That model is very compact, right? But it's not that much about ready for prime time in a sense that it needs a lot of computation power yet, right? And also, it needs a lot about the overhead. Again, this is more like a photogrammetry advancement. And so if you have a high-res photo and more overhead, you can get a clean result. And also, geometry from this is not as good as a typical traditional photogrammetry yet. And there are not many kind of idea to cover huge space like a Waymo style. It is a lot of computation. And so maybe it would take quite a while. You can see this type of the application on the web, right? So on the web means WebGL and also typical average GPU platform. And I think this is a great segue to give you some idea what we are up to, right? We are working on as a solution provider. So just this is a very typical, right? Computer vision tech stack, and we are working on all of this. And so SLAM photogrammetry, and also a lot of different type of image processing and scene intelligence, including point cloud segmentation, training, and then visualization. So that NERF is more like a visualization thing, but I believe there will have some interesting idea. We can blend this together, right? So visualization technology can help some better photogrammetry or vice versa. So, and then next question is, why on Earth world need another real capture solution like us, right? So there are already great solution available in the market, photogrammetry solution, mobile scanner, or terrestrial scanner. And the reason we work on this, this is our more like a problem definition. We are not Google, right? We are not NVIDIA. So we don't have that luxury of the resource work on many different problems. So instead, we want to work on just one narrowly focused problem. That is still, we believe, there's not much of a solution to provide a way to capture sight in a very fast, affordable, and easy way, right? And also, we did a lot of different product development, including SFM, high-res photo-based photogrammetry, but we boil down to this as a primary input device, which is 360 camera. And plus, not just 360 camera, but also that kind of a given condition, right? Very tough condition. Lighting is poor, and then there are a lot of object occlusion. And workers, they are moving objects. From computer vision perspective, that is really, really bad input. And also, space can be very big, right? And also, so the upside of a 360 camera is, one is cheap. So you can get the omnidirectional, right, visual input very quickly. And also, if you use the 360 video, it's much faster, right? And so not much of a learning curve at all. And also, we don't want our user to change any practice. Like, please clear the site, tidy up the site. Or please take a capture just a certain time of day, right? So we want our user to continue to do their current, just a typical workflow. Please do, you don't need to change anything, but use this only one single device, take a walk, and all the heavy lifting will be done from our end, right? And so that is a great scenario, but also this 360 camera itself has its own kind of a lot of some new problem, right? So its upside is cheap, affordable, and easy to use, and omnidirectional, but there's a image distortion, and if you're going to use the video, there are a lot of motion blur, and then pixel resolution is all the time the problem. So we work on this, right? So this is our domain. We want to be very special, and then we want to add some value on this. And so I think that this is also good, the moment to explain what we are working on. So what we want to do as a company. So this is our Cupix version of Flywheel, right, like Amazon's version. And so actually, I believe also, we believe that the technology can drive all this innovation, right? And also, so as the title implies, what's the distinctive boundary line between disruption versus hype, right? So I think there are some two kind of framework we can think this is disruption or hype, which is one is, I believe, that scalability. So eventually, it's not just one experimental lab environment solution, or you can use it every day, right, in a large scale. Scalability is one. And second one is value, why we do so. It's worthwhile all the painstaking, right, research and implementation. And so that is the main theme. And also we believe that all the affordability, scalability, accessibility can be achieved through technological, some innovation. So that is we are working on. So this is a couple of samples, I said. So again, our interest is, our focus, our narrow focus on 360 camera only, in any situation, any environment. And also, we are very interested in just automated some that kind of the idea, right? Digital workers, right? So on job site, possibly robot or drone, and then also in the middle, you can see that as well as a hard hand mount, we try to build on the workflow process. You can mount that 360 camera on this long boom pole, and you can scan that above ceiling, that height, very freely. And so using 360 and video, right? And by the way, we test out this spot robot 2 years before, and then hoping that it could be something very transformative. But our conclusion back then was it's not ready. It's not ready for prime time. Maybe it has been improved a lot. It was 2 years before. And also, we are very interested in some drone indoor environment. And so I like that idea about first person, right, the control. And if we can have some kind of idea, make it automatic, right, routine capture indoor using drone, it might be a better, right, better chance than robot. Right, as well as the taking the capture easily, quickly, automatically, or cheaply. Also, we do a lot of research, right? Like that design company, like image processing, and then computer vision, and then automation. So for instance, this is an example that each frame from video, we try to detect where is the sky, right? Because sky is not the computer vision friendly because there are moving cloud and many things. Also, we filter where is the people, where is a moving object, and segment it out, right, to process it correctly. And also, last year, we developed this is a kind of in-house tool, our engineer software, to visualize all the algorithm correctly. And so we try to train our AI model to detect the beam object from 360 photo, like here's a wall, right? Here's the MEPA object. And then try to match with this beam actual rendering to tell, right, this is installed, not installed, or how much deviated. But we also realize that this is not a viable solution because there are many challenging situations, right? Again, we don't want to ask the user to clean up, right? Clean up the site, tidy up site. There are a lot of occlusion, a lot of challenges. So we trigger a little bit our research direction to achieve this goal. And that is this one, right? So as well as a visual SLAM. So VI SLAM it means as visual inertial SLAM. So actually you use the IMU data as well as all the visual information. And also we developed our proprietary way to make it very, very accurate, very precise. Meaning that it is just it is not for real-time application, right? And so it's more like offline application. So we try to hybrid typical. So SFM is another nerdy word to describe photogrammetry. So position together at the same time using inertial visual and make a very accurate result. And so MVS is the next step to create the dense point cloud. We do all of this. The main reason to do this is this one. So like some solutions, the great other solution, we try to do a similar thing, right? So train the point cloud where is a beam or where is a column. At the same time, we try to calculate the deviation and then to tell, right, to verify how much the beam is done. Kind of that progress tracking information. It's more like our technological stack, the demonstration. There are a whole lot more detail. So this alone also doesn't solve the problem, right? So we try to put many different ideas, many different approach, AI, right, geometry, also image segmentation, point cloud segmentation, deviation analysis, many different things together. Why? We want to make it scalable, right? And then it should work many of the cases, right? Many challenging job site conditions it should work. And so we worked really hard. And so finally, we are about to roll out this new update of having this for progress tracking. Okay, so we saw almost a conclusion. So I took a little bit of putting all this different type of use case and all the solution in this innovators dilemma graph. And so maybe many of you wouldn't agree with this, but this is my like a personal view, right? There are different type of requirement in terms of performance. Performance means can be accuracy or coverage or things like that. And then, so there are many this type of use cases, right? Why we need to have a real-time capture? Why need to have a as-built condition? Right, easily, quickly, and accurately. And so we started from this one, right, just visual as-built documentation. And we keep pushing our technical boundary toward this direction. Now we believe that we crossed the line of this threshold of this photogrammetric result can be used for beam validation. Right? And so we believe that we hit that kind of the point, a tipping point about using this as a more like a real automated processing. Also, there are great, again, scan to beam is not our current focus, and there are a lot of some the great applications. So we try to partner with other company and put solution together to have some one complete platform solution. And so this one again, so NeurFsync. So where it is then, and so I believe this is very, very early phase. This is a long-term kind of idea, and long way to go. And we need to get over many different some challenges. But I think soon they will find their comfort, application like maybe film, because again, it costs a lot, right? You have to take a lot of photo, and then computation, you need the computation power. So maybe some less cost-sensitive application can accept this, and can adopt this. For instance, filmmaking, right? Maybe next time when you take a matrix again to create a slow motion, you don't need this many camera rig, right? Maybe you need just a few, and then you can synthesize in between kind of this the footage. Also, forensic crime scene. Anyway, they take a bunch of photos, right? What if you take just photo only and no scanner, but you can create a 3D scene more like very realistically, right? And so metaversing, mirror world, or virtual tour, maybe they'll have some chance because Google, possibly Metaport, many different big companies push this direction. And then I think the build-to application like us, maybe some find out the toughest application from this perspective. So maybe some simple visualization first, and then we can leverage this idea for beam validation eventually, scan to beam or further. But I don't know, right? It'll take 1 year or 10 years. So, but I think this is kind of a future we can envision, right, is coming along. So my point is that it's kind of my conclusion. So this neural rendering is very early phase. Basic experiment, it looks like a hype. But some big companies are working on for obvious reason, right? NVIDIA, they want to sell more GPU power, right? Google, they want to sell more location-based search, right? They want to provide more immersive experience. They push a lot. And then maybe some other vendor, Apple, Meta. And so when it reaches the tipping point, then maybe it has some potential to change everything. So I think we'd better prepare, right? But it's not tomorrow or possibly not next year. But I think we better, right, keep our eyes on this. So this very, right, just fantastic technology idea. Right, so one last thing is we are working on this too. So build-to-order application, right? So for as-built documentation, tough condition, right? Okay.